Good evening, everyone, and a very warm welcome to today's webinar, IBDP Science, What to Expect and How to Prepare. My name is Vrinda Bhandari, and I head the Academics Department at Sparkl. Thank you all for joining us today. Whether you're about to begin the diploma program or are already in it, this session is here to help you understand what DP Science assessments are all about and how to approach them with clarity and confidence. I'm delighted to be joined by Mr. Matthew Raggett, Head of Academic Council at Sparkl, a passionate physics instructor, a seasoned administrator, and an education evangelist. He's currently the director at Thuringia International School in Germany and has also served as the headmaster of the Doon School, Dehradun. Welcome, Matthew. We are so glad to have you here today.
Thank you very much, Vrinda. It's lovely to work with you again. I'm looking forward to sharing some of the things that we know help students do well in the IBDP sciences.
Absolutely, Matthew. So before we dive into the content, I'd like to take a moment to introduce Sparkl. At Sparkl, we don't believe in a one-size-fits-all approach. We follow a one-size-fits-one model, a truly bespoke way of learning. From international and national curricula like IB, IGCSE, CBSE, and AP to competitive exams such as NEET and JEE, we offer personalized one-on-one tutoring that helps students excel, not just in exams, but in life. Founded by the creators of Akash Institute and Merit Nation, Sparkl is driven by a singular vision, reimagining education through truly tailored learning experiences. If you'd like to know more, please feel free to visit our website after the session. Let me now walk you through the agenda for today. We'll start by exploring the nature of science, a core idea that underpins all the DP sciences, and then move on to the subject structures for physics, chemistry, and biology. We'll also decode the assessment objectives, command terms, and highlight the importance of tools such as the data booklet and the subject guide. Finally, we look at how students can prepare for exams and internal assessments. Before we jump into the content, we'd love to get to know you a little better. So I'm just going to launch a quick poll. So I request everyone to please take the poll. Thank you. So we have students from DP1 and both DP and MYP, and some parents also attending. So we hope the session is helpful and enriching for everyone who's joined us today. So let's begin. We'll begin with the foundation with something that connects all IB sciences, regardless of the subject or level, the nature of science. So Matthew, how does IB define the nature of science and its significance across all the disciplines?
Right. Well, this is one of the things straight away that makes the sciences at the DP different from the sciences at something like ISC or CBSE. So we're being invited to work and think like scientists, whether it's bio, chem, or physics. Facts are not science, just as a dictionary is not literature. And this is really at the very core of what we're expected to do. And as we'll see later on, it's at the core of the assessment as well. We're being invited to think about how science works. So if we look at the next slide, which has all of the elements of the nature of science on, what is it that we do as scientists? Well, we start by looking at the world. We observe, we ask questions that are scientific questions that we can test by designing an experiment. We collect data from our experiments. We look for evidence. We spot patterns and trends, and then we come up with theories. So if we look at one of these elements, like falsification, it's not a word that comes into our everyday language. But as scientists, we have to understand that we test ideas to see whether they can be shown to be wrong. And if it's wrong, then we falsified it and we move on to the next idea. As scientists, we are never going to be certain. We don't know that we're right. We just find out that we are less wrong. And I think it's a very important message for the world as well. The IBDP is getting us to think critically, to understand evidence. And again, we'll see in those exam papers shortly how this is going to be useful for reading the newspaper, looking at financial data and understanding what we're being told by people.
Right. So very different from what the regular meaning of the words is and truly thinking like scientists. So let's delve into the sciences, starting with biology.
Right, so the three classic sciences. In school, we've had these divided for years into these neat little subjects, but they cross over quite a lot in real life. And that's what we're going to be looking at as DP scientists. So the subjects break themselves down into different units and topics. So unity and diversity, form and function, interaction and interdependence. But biologists look at these from the perspectives of molecules, the very building blocks of life. And then how do those molecules arrange themselves into larger structures like cells? There's the next perspective that we look from. And then we go on to look at organisms, things like you and me and animals and plants. And then the bigger system in which those plants live, whether that's a temperate rainforest or a tundra or a desert, we're learning how life works in the different scenarios. And of course, that helps us understand our planet and our world better, which is going to help us manage our planet and our world better. So that's bio. If we look at the next topic, subject, which is chemistry, then chemistry is broken down into 6 topic areas, but really it's 2 aspects. There's what they call structure. So that's literally the models of matter, atoms, the atomic model, the periodic table, the way that those atoms fit together to make molecules, how molecules bond and form giant structures, and then how we classify matter based on things that we can measure, like temperature or volume or pressure. And then we're going to look at the way that these atoms and molecules react, not just interact, but actually change and form new things. What drives chemical reactions? How do we make reactions faster or slower or give a higher yield? So this is the foundation of industrial chemistry, of chemical engineering. That's the study of matter. And then the third science that we're looking at today in DP sciences is physics. So we're moving from the study of matter to the study of energy this time. And physics is broken up into 5 organizing themes: space, time, and motion, which is mechanics, the particulate nature of matter, a little bit of chemistry, and then the sort of physical understanding of how things join together. We're looking at wave behavior, so that's sound and light and electromagnetic waves. That moves us on to fields, and then nuclear and quantum physics. But in all of these, we're invited to take a bigger picture to see how they're connected to one another. Because, I mean, let's recognize wave behavior. We're talking about electromagnetic energy. If it wasn't for that, plants wouldn't photosynthesize. We wouldn't be able to grow food that's going to actually allow our larger organisms to live. Science is not this discrete subject. It's related to lots of things. And that's how scientists think.
Right. So all of these 3 are, they have an overarching theme, and then there are topics within them.
Right. And again, you're a mathematician, aren't you? We're using mathematics as a very valuable tool to help us do the work of understanding things. Statistically in biology, we're looking at equations and yields in chemistry, and then we're looking at applied mathematics, really, in physics. It's all related.
Absolutely. So moving further, as students transition into the IB science courses, they often encounter a very big shift in terms of the learning methodology. And, you know, they're just trained to memorize or just write down equations. So how do students, you know, move on to IBDP science from this methodology?
Yeah, and I think that 30% of the people watching are parents as well. When we were at school, when you and I were at school, we had to learn a lot of things, didn't we? I remember learning my equations before I went into the exam, writing them down as quickly as I could. We don't have to do that anymore. We're not just learning definitions and facts. That's really general knowledge. Science is not a general knowledge course any longer. What we're learning is, how do we apply our scientific knowledge and understanding to unfamiliar situations or to real life situations, so that we can make connections between what we're learning in school and what's going on in the outside world? I mean, after all, we don't need doctors and engineers who can solve problems that we already know how to solve, right? We've got to look at novel solutions to big problems. So for IB Sciences, we're really practicing our imagination, our thinking skills. We're practicing our interconnectedness. We've got to be better at writing than we used to be, because we have to be clear and concise in our language so that there is only one meaning. It's really important as a doctor that you only have one meaning to what you're saying about a patient. And then making interpretations and predictions is how we actually apply our scientific knowledge to those new problems. And we'll see together that this is what the assessments are asking us to do. And it's what the tutors at Sparkl are doing when we're working with students. Because often we find that teachers teach the way they were taught. We can't help it in schools. We often are trying to prepare only for the tests, but we are really helping our students think differently and prepare for life.
Absolutely. And I think it is very important to understand how to approach rather than just writing simply or memorizing.
Absolutely. I mean, and that's what makes people great to work with, isn't it? If we all think about whatever we do in life, the people who are best to work with are those who can see things differently and think differently. If all we can do is say, yes, yes, and, oh, I know how to do that, we're not going to get very far.
Absolutely true. Let's move on to our next segment, which is the assessment objective. So we know assessments, of course, are central to the IBDP. So Matthew, could you please take us through the assessment objectives in science and what is the relevance and importance of these assessment objectives for our students?
Right. So every single DP subject, the English, the mathematics, the German, the film studies, they all have assessment objectives. And this is what tells the teachers they need to be preparing their students to be able to do. So the very first one there, we have to demonstrate knowledge of terminology, facts, concepts. That really is what ISC sciences test you on and mathematics tests you on. If we move to the next level, number 2, understand and apply our knowledge, then we're looking at taking the skills, techniques, and methods that we've learned and turning it to something we've not seen before. We're going to be prepared to do that in our classes and teaching so that when we are assessed, we can actually do things that we've not seen before. Analyzing, evaluating, and synthesizing, we'll see that one of the exam papers is a very much a data-based assessment. So we're given information just like we are in real life, and we're invited to do things with it and to draw conclusions, to spot trends and patterns and make predictions. And we're also expected to understand how did we get hold of that data, understanding the experimental procedures, maybe even understanding the ethics of an experimental procedure. In biology, we're not allowed to experiment on ourselves and on animals. There's a good reason for that. But why is it that in bio we get a set of maybe 10 data points, but in physics we can get 50,000 in a second? There's a fundamental difference in the type of experiment that we're doing. And number 4 there, demonstrate an application of skills to carry out investigations which are insightful and ethical. This is about how scientists get the evidence that they need to come up with their conclusions. And we're going to be looking at internal assessment just a little bit today, because we'll do a webinar on that again in the future.
Yes, so they really are crucial, and students often overlook the assessment objectives, but this is really the roadmap to how they're going to be assessed.
Right, we just think of science exams as being calculations and answers, but we'll see very shortly that it's a little bit more than that in the DP.
Yes, so moving on to the command terms. So every assessment objective that we just saw has a certain set of command terms associated with it.
Right, so when we think back to our schooling, we had to learn equations, we had to learn laws and definitions. This, I suppose, is what we do have to learn for science in the DP. We have to learn what the command terms mean, because these are the instructions we're given in assessments. So to demonstrate knowledge, we might be given the command term, the word draw. We're perhaps told to draw a diagram of. So what that means is a labeled, accurate, scale drawing Using a pencil, it even says that, use a pencil. If you're using a pen, it's not a drawing. If we're putting a straight edge there, we use a ruler. That's how we make it look correct. If we're drawing a graph, we have to join points either with a straight line, if it's a linear graph, or we know that we have to draw a nice smooth curve. We have to practice doing that. The next command term there, calculate, obtain a numerical answer showing the relevant stages in working. This means that I am not just putting the answer. I have to show every stage in my calculation to show an examiner, this is how I got to my solution. The opposite of that is write down. There, I would just have to put an answer. Another command term is explain. So that means give a detailed account, including reasons and causes. We'll look at an example of this later on in an assessment, but it doesn't mean describe. It doesn't just mean write a sentence which sounds nice and has some words in. It actually means reason A, reason B, causation, justification. And this is, of course, great training, not just for science, but this is great training for law. It's great training for writing. All of these skills are going to help us be better communicators in life.
Absolutely. And I think this really highlights how precise language is key to assessment. So students also who've joined us who are in MYP should be able to relate to this, because in MYP, command terms are really highlighted throughout the curriculum.
Right. And we're going to look at the data booklet shortly, but having the list of command terms above your desk, by your bed, these are the things that we're learning, because it's going to make us much more effective as scientists, but also in answering those questions for assessment.
Yes. Now let's move on to the tools that support students during exams, particularly in physics and chemistry. We'll start with the data booklet.
Right, so biologists don't have a data booklet, but in chemistry and physics, this is the document that you and I wish we had when we were at school. So all of those equations, all the definitions, the laws, the SI units, all the fundamental constants, we don't have to remember them. Although, of course, you and I do, because we just had to learn them.
Students are really fascinated by that
yeah.
we remember it.
So we get given this list. So here's the first part of the physics data booklet: space, time and motion, kinematics, and I've got my equations of constant acceleration. But as a student, what I should be doing with my data booklet, it should be at the front of a physical binder with my physical notes, and I should be annotating this. Just like a literature student would annotate a poem or a short story or a play, we need to be writing things on our data booklet. So what does S mean? What does U mean? It has units. Do I know the units of all of these things? So I'm writing all of that down. What do those signs mean? The plus, or what if it's a minus sign? It's about direction. These are vector quantities. So I label it and I write it on here. And when do these apply? They don't apply if I have a changing force acting. So for example, if I'm accelerating towards a black hole, these are not useful. And I need to know the limits of these equations. So I write it on my data booklet. So that I build this fantastic document as I go through the course, which is going to be really useful when I'm studying for my assessments at the end of the program. Now, I can't take my data booklet in, but by the time I've annotated it and read it, I pretty much know what's on there.
Yes. So students actually often leave it to the end. They just take it out when there is an examination. And I think it's really crucial that they have it with them throughout the course for every class that they take.
Right, it's a living document, and it's exactly the same. I think the next slide is the course guide. So often we are shown this by our teacher at the start of the course. Maybe it's on Manage Back and they say, go and look at the course guide, it's there. Maybe they print it out. It's about 60 pages. But really, again, front of our binder, we need to have this as an annotated record as we go through the course. So they're all written in a similar way. They have the topic, they have the theme, the topic, these guiding questions. How can motion of a body be described quantitatively and qualitatively? So these are the describing questions at the start of each topic that my teacher might use to get into the subject, or that I might use to get me thinking about, how do I predict the position of something in space and time? What do I need to know in order to do that? Well, I need to know where it starts from to begin with. The understandings section in every guidebook is telling me what the content of the course is. So I'm understanding the motion of bodies in space and time described in terms of position, velocity, and acceleration. Those were the things in my data booklet, in those equations of motion. The guidance here is about telling me and the teacher where the limit of this topic is. So the trajectory of projectile motion is parabolic. I need to know that in the absence of air resistance, but I don't need to know anything about the equation of motion for that trajectory. So there's the limit of this topic. And the linking questions in the subject guide, they help me make connections from this topic to another topic later on. And I will be asked when I'm doing my assessments to make comparisons between electric and gravitational fields, although they're not taught in the same topic usually. If you're doing a thematic approach, then you might look at electric and gravitational fields at the same time. But usually we stick to gravitation, energy, and mechanics, and then later on we do electricity and electrostatics. But that's how useful the subject guide is. And again, it's a learning, usable document as I go through the course.
Absolutely. So I think students who are attending this have understood the importance. And if you've not been using these, I hope you start using them actively now in your learning journey. So,
and you can also make the links here, can't you, with this document and the data booklet. So on this page, there are 4 equations I could write down so that I know it's exactly about equations of constant acceleration here.
Yes. We've looked at the tools that are used for assessments. Let's come to the actual assessment. So we'll start with understanding the assessment model. Matthew, could you please take us through the assessment model?
Absolutely. So whether we're doing standard or higher level, we're going to have 2 examination papers. Paper 1 is multiple choice with data-based questions. Paper 2 is short and long response questions. Some of those are questions over 5 pages. They make up 36% and 44% of my final mark, respectively. And then 20% of our mark is given by what we do in school, our internal assessment. We'll look a little bit at that at the end. The difference between higher and standard is the amount of time I spend on the material. That's in school, 4 lessons a week or 6 lessons a week for standard and higher. So my higher level exams are just a little bit longer, half an hour longer for paper 1, 1 hour longer for paper 2.
Yes. Now, I think we'll move on to the most awaited segment, which is where we are actually looking at the exam questions and understanding how to approach, starting with paper 1A MCQ in physics.
Right. So if you're going to be doing multiple choice questions, there's a few key rules to remember. The first is don't look at the answers. Read the question and figure out what the answer is, and then check to see if the answer's there. Otherwise, you can get distracted too easily. So we've got a car that has an initial speed, that's S. It decelerates, that's A. And then it stops. Final speed is 0. So I need an equation that has S, V, U, and A in it. And I'm trying to find S, and that's going to give me my answer of 32 meters, rearranging the correct equation, which I got from the data booklet. It's there. So here's another question. Now this one, again, I don't need to look at the answers. I'm being tested not on an equation, but on a concept. So I've got a bird sitting on a wire at the midpoint, and I'm being asked what the tension in the rope is. If the bird is there and the thing is not falling through the rope, I have to know that the tension in the rope is greater than the weight of the bird because it has to support itself and the bird. So that's going to be the answer D. So a different type of question. One was, can I use an equation? The next one is, do I understand a concept? Let's look at an example from biology now. So here I'm being asked whether I know 2 things about a body and homeostasis. So how does a body respond to a rise in normal body temperature? Well, if my temperature goes up, my body will respond by trying to drop my temperature. That's a negative feedback loop. Otherwise, I just get hotter and hotter. And how do I do that? Well, I've got two possibilities, but I know that when I get hot, I get red, and that's because I've got increased blood flow to my skin blood vessels. So that's the answer that I'm going to take there. Another biology question where I'm looking at 3 different species of animal that live in different temperatures. I can see that all of these temperatures cross over. They can all live in 12-degree water. One of these can live at a much lower temperature. So this one I have to actually read the answers first to see which one of those fits my bottom choices. So all of these 3 species overlap. They can all live in the same water temperature, as long as the temperature is 12 degrees. Brown trout are the most specialized. No, they're not, because they can live at the top end, but they can't live at the bottom end, and it crosses over the other 3. So it's going to be the lake trout that can avoid competition by living in colder water. The other 2 can't. So it's 1 and 3 only. So again, I have to know something about these animals, and I have to understand the ecosystem in which they're living as well. So there's bio. Let's look at a chemistry example. Now these ones, this is an interesting one. So again, this is not general knowledge. I can't know this unless I understand what cyclohexane is, and I have to understand what a nuclear magnetic resonance spectrum is. So cyclohexane is a ring of 6 carbons. Each carbon has 2 hydrogens on it, and every bond length is identical, which means if I make them vibrate, then I'll only see one result, because all bonds are the same. So that's going to give me the reading I get on A, because there's only one bond length being vibrated there. And here's another one where I've got to understand 2 aspects of something. Reactions, I've got reactants at one energy level, I've got products at another. I'm giving out energy. I'm lowering my energy to become a product, which means I'm going to give out thermal energy. It's an exothermic reaction, so my temperature increases. These are all things where I'm having to understand the process or understand a structure. It's not just knowing something that's going to give me an answer. So those are the multiple choice questions.
Yes, so sometimes I think students also tend to take this a little bit lightly, that it's just multiple choice. But as we've seen, I think it's very important to be able to understand the concept behind it and how to approach it.
Really, and we've got to remember as well, we don't have much time for these. So if you get stuck on an MCQ, just move on. Don't waste time on it. And if you're ending up guessing, then just do that in the last 30 seconds, right? Don't use guessing as a strategy for the whole thing. Yeah.
That's actually very tempting for MCQs. So
the next type of questions.
Yeah.
So paper 1B, now we've got these data-based questions. So let's look at one example. It's taken from a physics exam, but it could be bio or chemistry. They use very, very similar sets of results. So here we're given a graph, and the question is, outline why it is unlikely that the relationship between T and V is linear. Well, if it was linear, I could draw a straight line through it. Straight lines are always drawn with a ruler. So I can do that on the graph. Oh, look, it doesn't go through the points. And then I have to write that down. A straight line cannot be drawn through the points. It's only a 1-mark question. So there's not a deep understanding, but then the command term was only outline. It wasn't explained. So it's a 1-marker. Straight line cannot be drawn. What's the next question? I bet it's worth more points. Yeah, so it's worth 2 points, isn't it, this question now? So it says calculate. So I have to show my working the largest fractional uncertainty in T for these data. So the first thing I'm being asked to understand is that the largest uncertainty is going to be for the lowest value of T, because the uncertainty is the same for every one of those data points. It's 0.1 seconds. So for the lowest value of T, that's when T is 0.5. So 0.1 from 0.5 is a fractional uncertainty of 1/5, or 0.2, or 20%. So I've written each stage down to get my 2 marks. The next question, so now you can see how the question moves from one stage to the next to the next. This is worth 3 marks. The student suggests a following relationship where T is equal to A over V, and A is a constant. To verify that, we've plotted a graph of T against 1 over V. And I'm being asked to determine A, that's the gradient of that straight line, by drawing a line of best fit. So I have to draw a good line of best fit. That's with a ruler. And then to find the gradient, I have to draw the biggest possible change in y and change in x triangle that I can on the graph. And then I put in the values for change in y divided by change in x. And I get here 4.11. Now, if I make a slight mistake, if my line is not perfectly straight, I might get 4.13. I'm going to be allowed a little bit of error in my answer, but not a huge amount. So I have to be very careful when I do this. But notice that I didn't have to get the last answer right to get this answer right. And it's a lovely thing about these IBDP exams is that they're interesting questions where I don't get punished as I go through if I didn't get it right. I'm just being asked to think more deeply each time and show what I know. Let's see how it finishes. I think there's a 1-mark question at the end, isn't there? Here we go. State the units of A. So state means just write them down. The units of A are kilovolts seconds. And I just know that from the graph because change in Y divided by change in X is kilovolt seconds. So that's a data-based question.
So how are data-based questions in chemistry and biology?
Well, they're really similar because what we're doing in all of our sciences is we're taking data, we're graphing data, we're doing calculations with data in order to find something and then come up with a conclusion. So they're very, very similar. I mean, this could just be an ideal gas question. This could be a chemistry question, for example.
Right.
Yeah. It could be an absorption of CO2 data-based question in biology. I'd have exactly the same graphs and the same equations to test.
This could also be mathematics.
Well, yeah, mathematics is everything, isn't it, Vrinda? That's why we love it.
Yeah, we certainly do. So moving on, so we'll just look at how we've been trained on certain questions and how they differ for the same topic in IBDP
Right, so,
as opposed to the national curriculums.
Yeah, so we said this right at the beginning, and I think it's worth emphasizing here before we look at a long response question. So if I was going to do a physics question about satellites in ISC, there it is. It's a two-sentence question. I get given the information they're prepared to give me. I have to know all of my laws, all of my equations, and then I have to just keep plugging through a calculation to find H. Let's look at an IBDP version of this, and then we'll see how we're being led through some thinking and asked what we know. So to start with, here's a satellite moving around the Earth. Draw an arrow on the diagram to represent the direction of the acceleration. So drawing, that's with a pencil, and it's a straight line. So I'm using a ruler to draw a vector down towards the center of the Earth, showing that I understand what centripetal force or what gravitational force is doing. There you go, 1 mark, simple instruction. The next part, again, it's only 1 mark and it looks complicated, but let's see. I'm given the following data, so I don't need to remember any of this. I'm told what Kepler's third law of motion is, T squared equals kr cubed. So again, I didn't remember that. And I'm just being asked to show that the constant is 4 pi squared over gm. All I'm doing here is I'm choosing which 2 equations I'm going to make equal to each other from my data booklet, and then I'm rearranging them. I bet this is going to help me answer the next question, though, because it's only 1 mark for rearranging. So here we go. Determine the height of the satellite. Now, that was the question on that ISC paper that we looked at a moment ago. Determine the height of the satellite. So now I have to correctly rearrange Kepler's third law, and I have to remember to subtract the radius of the Earth, and then I get the height of the satellite above the surface. 2 marks for that one. Oh, 3 marks now. So I'm being asked to think a little bit more. The atmosphere exerts a small viscous drag on the satellite. Outline, oh, now this is the instruction. Outline how total energy, kinetic energy, and gravitational potential energy change. So there's 4 things, 3 energies and change as the satellite goes around. So here I can do this in bullet points, or I can write sentences, but I have got to use in each sentence total energy either goes up or down. That's the change. So total energy goes down. I know energy is conserved, but if there's a drag force, an external force acting, then the energy is reduced. Because that happens, then there's a decrease in radius. That means that my kinetic energy is going to increase. Where did that energy go? The thing got faster as it came in. That's why satellites burn up, because their speed increases, they get hot. And then I've got a decrease in potential energy. As I get closer to the Earth, I'm losing that height. So there's the decrease. So again, I'm being a good communicator there, but I'm doing exactly what it told me to do. I have to refer to those three things and what the change was. There's my 3 marks.
So these questions are really guided, and the previous parts are referred to, or the subsequent parts follow through from the previous parts.
Right, and it doesn't necessarily mean that they're easier. I still have to know what I'm doing at each stage. But if I got anything wrong before, it doesn't ruin my chance next. I can still do well by knowing that part. But I'm being invited to think more carefully as I go through. I'm not losing my way through a question and thinking, what do I do next? Because that doesn't test a student's understanding of the world. That just tests an understanding of, do I know how to do exactly that question? I think is there another part to this, or have we got to the end of that physics question?
No, we've got to the end, and we can now take a look at the example from biology, paper 2.
Yeah, so physics and chemistry papers are pretty similar in the way they're structured, but the biology questions on paper 2, at the very end, I've got a choice of 2 out of 3 questions, where these are almost like little essay questions. So this question is inviting me to think about the advantages of specificity, explain how vaccination can result in specific immunity to a viral disease. 7 marks. Okay, that is quite a lot, isn't it? So I must have to have 7 things that I know that are connected. And it says explain. So explain means reasons, causes, consequences. So I need to start at the top. Yeah. So do vaccines work for everything? No, they don't. I need a COVID vaccine for COVID. So they're specific to a specific disease. One thing. They contain antigens made from pathogens. That's the next thing. Do I know what a vaccine is? They trigger live versions of the virus, but attenuated. That's the next part. So I'm gonna list through the whole thinking. That's what explain means, of how vaccines actually work, all the way down to providing long-term immunity, because I've got these memory cells that trigger an immediate response if I get that virus, that infection.
Yeah, so this looks like students need to memorize this, but I saw how you just, built on the points, or from the first point you moved on to the next point and so on.
Right, it's not, I don't learn these 7 points. I understand how a vaccine works, and then I become practiced at communicating how a vaccine works. And that's what I'm doing on my exam paper. And again, this is exactly what our tutors at Sparkl are doing in those one-to-one sessions with our students, because it's tough sometimes to get the practice that you need doing this in school, in a class with all those other people. And again, it's something that we offer and do very well.
Yes, and writing is really important, because sometimes you just know it, but you're not able to structure the answer very well.
Right, and again, we ask our children and our students, do you know that? Do you understand that? And it's not a good question, actually. We should test understanding by asking good questions, but it's too easy to say, oh yeah, no, I know that. And then when you say, okay, can you write it down for me? That's when you see whether somebody knows something. Because if you can't write it down, then you don't know it.
Absolutely. So we have looked at examples of questions from all the 3 external papers. We'll now just briefly give you an overview of the internal assessment, which is 20% of the overall marks, and something that the students, I would say, find difficult.
Right, and let's just think about how important this is. 20% of your marks. That's the difference between one grade or another, but for some grades, it's the difference of 2 grades. Yeah. So I can get this done before I even have to go into an exam room. So it's a scientific investigation where I'm being invited to come up with a research question, design an experiment, collect data that I analyze, and then draw conclusions and test them to make predictions. And then I evaluate whether or not I've done a good job by looking at how different my results might be from what might be expected, or whether my prediction can be shown to be true by repeating an experiment with slightly different variables. And it really is a great way of behaving like a scientist. Now, this is part of our science course. Our teachers will be doing practical work as we go through. But again, it's something that at Sparkl we support by helping people understand what's a good scientific research question? What's a good design for an experiment? What could go wrong with that? How do I evaluate this? And I think that, Vrinda, you and I will probably do a webinar just on this topic in the future, because having 20% of your marks before you go into the exam is incredibly valuable.
Certainly, and I think what you just said about having to choose a research question, I think that's the very first step, and that is where students struggle the most.
Right. And we also have to, you know, I teach theory of knowledge in my school, choosing which of the TOK questions you're going to approach, and then choosing the direction you're going to head in, because they're not even direct questions. They are opening statements that you are invited to explore, and making that choice of where do I head. For a lot of students, it's really tough because you don't know whether you're right or not. But let's let you into a secret. You never know whether you're right or not when you're doing sciences. That's how we work. It's the same in medicine too. So yeah, we've got to be prepared for this. It's a skill, but it's also a resilience that we're developing in our students.
Yes, and certainly we will be talking about this later in another webinar, because this is a lot of hard work and effort that students put, and to be able to break down the criteria and to unpack them and understand them and how to put them into words is something we'll be doing at a later time. So that brings us to the end of our presentation, and we will be opening up for questions. But before we open up the floor for questions, I just want to quickly share what we do at Sparkl. So if you've been a part of our learning community already, you know that we offer personalized one-on-one support across IB, IGCSE, CBSE, AP, NEET, and JEE. And if this is your first time engaging with us, we'd love to connect, whether it's just for academic help, subject planning, or just to make your learning journey a little less stressful. You will see our details on the screen, so please feel free to reach out to us anytime. And with that, let's open up the floor for Q&A. You're welcome to drop your questions in the chat.
This is my favorite part of the presentation, Vrinda. Well, have we got any questions yet?
Yes. We do have questions. Let me start. Okay, so we have the first one from a student who's in grade 10. So how should I decide which science subject to take in DP?
Hey, that's a good question. So I think that the first thing is probably knowing yourself. Who wants you to take sciences? Who's choosing your future path? If your future path is going to be something like engineering or medicine, then there's pretty clear choices. We've got to take chemistry and probably bio for medicine as well. If we're going into engineering or chem-eng, we'd better be taking physics and chemistry, certainly physics for engineering. So there's that thing. Have an eye on what you might like to do in the future. But parents, be gentle with your children and make sure that they're doing something that they enjoy, because really the key to success in sciences is, do you like it? And I think it's the same with mathematics, isn't it, Vrinda? You and I love mathematics. There are different levels of mathematics in the diploma program. And I know that my daughter did not enjoy mathematics. So there was a natural choice for her to do. I loved mathematics, and I chose the sort of the higher level analytical mathematics rather than the methods mathematics, the applied stuff. So, let your children drive that one. Do what makes you happiest. And you often find that, hey, you're quite successful at that thing.
Absolutely. And just as a follow-up, there are certain students who don't study discrete sciences at grade 10. So they are either studying integrated sciences or coordinated sciences. So how does that work if they had to choose physics, chemistry, or biology at the DP level?
Yeah, and there's no formal requirement at DP level that you've done any particular science. So it does allow anybody to go in. But I mean, let's recognize that certainly chem and physics, I think, have been the challenging ones for many of our DP students. And you've got time to do a bit of reading. So again, it's funny. The things you enjoy, you do well in. The things that you put a bit of hard work into, you do well in as well. Yeah? The more you practice, the luckier you get. So do some of that reading. I remember discovering a dictionary of physics and thinking, wow, if I'd have read this before I started my A-level physics, back then I didn't do IB, but I advise my physics students as well, get your nose into a dictionary of physics, learn these laws, learn how they're connected. Dictionaries are brilliant at going backwards and forwards. So build some connections before you get into the classroom. It's always good being a few days ahead rather than a few days behind. If you are running to catch up, rather than if you're prepared, if you've read these words, if you understand what your teacher is talking about when you go into the class, life is better. So do a bit of work beforehand.
Absolutely. And also have your data booklet and subject guide beforehand, so that will be further helpful.
Yeah, that's really valuable. What other questions have we got there?
Yes, we have Pravit is asking, what is the most effective way to review concepts?
So you can read. There's an awful lot to read. There's a lot of textbooks. They have summaries at the end, and those are valuable. But honestly, doing questions, and it doesn't have to be old IB questions. It can just be questions in this book, that book. The more questions you try, the more you practice. It's exactly the same in mathematics. It's the same in languages too. You have to use it to then be familiar with it. But certainly when it comes to, December, January of DP2, you are using past paper questions to become very, very familiar with the pattern of questions that get asked, so that when you go into your final exam, you are secure in knowing that this is a question about this theme, that topic. These are the equations I'm going to put to practice, and this is how I'm going to explain my understanding.
Okay, we have another one from Tanushree. My subjects are biology, physics, chemistry, and math AA. So HLs in biology, chemistry, and math AA. And I struggle with paper 2 questions in physics. So how do I get better?
Again, I almost just gave that answer. It is about practice, isn't it? But again, with physics, I suppose it's my concepts that are really being tested. And I suppose that it may even be my own ability to communicate that's being tested here. So I may have a decent understanding of how to solve problems with calculations, but I've not practiced writing about it and putting those sentences into real English on paper. So putting that practice in, I think, is going to be the most helpful. I also find that, how much do you listen to that is scientific? So listening to certain podcasts is going to help me grow my scientific vocabulary and the clarity with which I communicate. So choose some decent podcasts that are going to help grow that fluency of response.
Okay. We have another one. A student is at the end of DP1 currently, and how do they make DP2 less stressful? And how do they plan out their IEs and EEs in biology?
Yeah, I mean, and again, what is there between DP1 and DP2? Well, there's a holiday, and let's recognize that the work we put in now is an investment in our future. So I think that spending some of that holiday and some of that time doing the work that's going to keep me ahead rather than behind. I mean, it is not every student believes us when we say this, but for the kids that listen and they try it, it is revolutionary. And it's how a lot of very successful students operate. You need to be a week ahead. You've got the course guide. You know what's coming next. It is not a surprise. Put in a bit of time. The most effective homework is the homework you do before the lesson, not the homework that you do after the lesson. And I think that will relieve a lot of the pressure. And again, the other thing is that schools publish, in DP2, schools publish their internal assessment timetables. They design it so that people are not doing lots of things at the same time. Stick to those deadlines. If you are getting behind and if you think you can negotiate a deadline, you are making a mistake, because you're then going to have to negotiate every deadline. And I'm sorry, but that's not how life works. And if you think that